Physics Part 341. The electron mass. How do you find the mass of an electron? This cannot be done directly, but the ratio of the charge of mass ELM can be found, and knowing the charge E on the electron, the mass M can then be calculated. We have seen that a particle of mass m and charge q moving with the speed v at right angles to a uniform magnetic field of flux density b experiences a force Fb given by Fb is equal to bqv. The direction of this force is given by Fleming's left-hand rule and is always normal to the velocity. The fact that we have a constant force which is normal to the direction of the motion is the condition necessary for circular motion. The force Fb provides centripetal force. The motion can be represented by the equation bqv is equal to mv square divided by r. Rearranging the terms, q over m is equal to v divided by br. The ratio ELM for an electron, sometimes referred to as a specific charge, may be determined using a fine beam tube as shown in the figure. The path of electron is made visible by having low pressure gas in the tube, and thus the radius of the orbit may be measured. By accelerating the electrons through the radius of the orbit may be measured. By accelerating the electrons through a known potential difference, their speed on entry into the region of the magnetic field may be calculated. The magnetic field is provided by a pair of current-carrying coils, Helmholtz coils. It is of interest to rotate the tube slightly so that the velocity of the electrons is not normal to the magnetic field. In this case, the path of the electrons is seen to be a helix, rather like coil of a spring. The component of the velocity normal to the field gives rise to circular motion. However, there is also a component of velocity along the direction of the field. There is no force on the electrons resulting from this component of velocity. Consequently, the electrons execute circular motion